Hello students, how are you all? I believe all of you are doing well. So children, today's topic is average atomic mass of isotopic mixtures. You might have seen sometimes some elements are having atomic mass which is 35.5, or you can talk about copper which is 63.5, isn't it? Here, what is actually atomic mass? What is actually atomic mass? As we all know, atomic mass is equal to number of neutrons plus number of protons, and we consider both of them as 1 AMU and 1 AMU, isn't it? So after combining, how we are getting fractional values? So this is due to the mixture of isotopes. How? Let us understand. Here you see carbon is having three isotopes, which is C12, C13 and C14. Okay, this is basically C14. Three different isotopes. But C12 isotope is around 99.99% of abundance which is having on the surface of Earth. So this 99.99% mass, I mean C12 actually defining mass, and if you see, this is present in 99.99%. So usually we are writing carbon's atomic mass as 12. But if you talk about chlorine, you see chlorine has two isotopes. One is Cl37, one is Cl35. And if you talk about percentage of abundance, Cl37 is 25%, whereas Cl37 is 75%. Right? So you can't even overlook anyone. So both of their atomic mass should be considered. Why it should be considered? If you have a chlorine ore and you are scooping out, okay, if you are scooping out 100 gram of chlorine, or you say 100 mole of chlorines, okay, 100 mole of chlorine atom, then it will be, according to this data, 75% chlorine will be of Cl35 and 25% of chlorine will be Cl37. So we have to find a way by which we can find out an average mass of chlorine, right? So basically, what do you mean by isotopic mixture? Isotopic mixture is an element where element's atomic number is same in both the cases, but mass number is different, M1 and M2. Okay. So percentage of abundance, what do you mean by percentage of abundance? How much amount of this particular isotope is existing on the surface of Earth, right? So this is A, this is B. Suppose two different elements we have taken, and A plus B collectively we have taken 100. Children, whenever in exam percentage of abundance is given, you need to understand that percentage of abundance is basically mole percentage also. Okay, it is basically mole percentage also. So let us find out formulas and all for these things. You might have seen in exam or in your NCERT book, they have given a formula. Actually, average atomic mass A is equal to M1A plus M2B divided by A plus B. Such type of formulas you will be getting. How these formulas came into picture, we'll understand. For a single substance, what is the formula of number of moles we have read in our previous classes, which is given mass by molar mass. If you want molar mass, what will you do? Mass of the substance divided by number of moles you will do, isn't it? So molar mass is basically, suppose if they will talk about atomic mass, what will you do? Mass of the substance divided by moles of an element. The same way, mixture के लिए क्या होगा? What will happen? What is this for mixture? Same, average atomic mass of the mixture is equal to total mass of the mixture divided by total moles of the mixture. See, atomic mass is equal to mass of a substance divided by mass of element. The same way, average atomic mass of the mixture is equal to total mass of the mixture divided by total moles of the mixture. That's it. Okay, so M average is equal to W total, weight total divided by N total. It's that easy. Now the point is how to find mass, sir. Sir, how to find independently mass? Children, as I told you, the same formula, isn't it? If you see the same formula, mass of substance will be atomic mass multiplied by moles of the element. So here the same thing we will do. Mass will be M1 into A and M2 into B. Sir, what is A and B? Here you see, children, A and B. A is basically percentage of abundance. B is also percentage of abundance of this isotope. Hai? Two isotopes abundance. So what will you do? Mole percentage multiplied by its molar mass. Mole percentage into molar mass if you'll do. So both of their weight you got. So M average is equal to WT. Total, how it will be? M1A plus M2B divided by A plus B. Where M1 is molar mass of isotope 1, where M2 is molar mass of isotope B, or molar mass isotope 2, molar mass of isotope 2. Here A is percentage of abundance, whereas B is also percentage of abundance. Okay, so now let us put it in formula. 35, 37, 75%, 25%, 35 into 75 plus 37 into 25 divided by 75 plus 25. What is the answer? You got 35.5. This is the reason we are telling chlorine's atomic mass is 35.5. So finding what we got out of it. If an element has fractional mass number, it suggests this element exists in the form of isotopes. I hope I am clear. Anytime if you are saying copper 63.5. So sir, why it is 63.5? Because it has few isotopes whose isotopes mixture of mass is 63.5. So whenever an element's atomic mass or mass number is fractional, you need to understand that it is existing in the form of isotopes. Okay, very fine numericals I have bought regarding this topic. Let us see. One such numerical is boron exists in the nature in the form of B10 and B12. If atomic mass of boron is 10.8 mu, then calculate the percentage of B11 in the mixture. Okay, so they are telling that there are two isotopes called B10 and B11 of boron, and average atomic mass is 10.8 mu. Then calculate the percentage of B11 in the mixture. You can pause the video and you can solve. If not, you see the answer. Still, it is given B's atomic mass is 10.8 mu, whereas B10 and B11, we don't know the percentage of existence, isn't it, or abundance. So here mole percentage will be how much? If B11 it is asked, so let us take it as X. So other one will be 100 minus X, because I told you whatever isotopes are there, overall should be 100, and a percentage of abundance should be, overall abundance should be 100. The same way, mole percentage, if it is 100 minus X and it is X, solve it. M average is equal to M1A plus M2B plus A plus B. 10.8 is equal to 10 into 100 minus X plus 11 into X, 100 minus X plus X. So what we got? If you'll solve, you see 10.8, 1000 minus 10x plus 11x by 100, and you got 1080, 100 minus x, 1000 minus x, or x is equal to 80. So B10 is existing in the form of, B10 is 20% of abundance, whereas B11 is 80%, because we have taken B11 as x, and x we got 80, so 80% of abundance it is having. So your answer is, the percentage of B11 is how much? 80%. This is one such easy question. One more question, children, for you. A mixture contains magnesium 24, magnesium 25, magnesium 26, has an average atomic mass which is 24.31 mu. If the mixture contains 79 mole percentage of Mg24, then calculate the percentage of Mg26. See, the same way, magnesium we have taken 24.31 mu. 24 is directly given 79%, we got it. But 25 and Mg26, how much they will have? Rest 21%, both of them are having. So I've taken Mg25 as 21 minus X and 26 as X, because X is asked. Okay, so 79%, this is 21 minus X, this is X. You see, this is your, we'll do it later. Answer will be around 11 and 10. How? We'll see. M average 24.31 is equal to 24 into 79 plus 25 into 21 minus X plus 26X. Children, the formula is same. M average is equal to, what are they? M1A plus M2B plus M3C. Even that is possible. Divided by how much? A plus B plus C. Total mass divided by total moles. Okay. So what exactly you are getting over here? So 2431 is equal to, the thing you can solve very easily, and we found out X value is surprisingly 10. If X value is 10, 21 minus X will be 11, and everybody's percentage of abundance, you got it. So when we are talking about isotopes, let us understand all other topics also. What are isoelectronic species? The species which are having same number of electrons, okay, are called isoelectronic species. O2 minus, F minus, Ne, Na plus, Mg2 plus, all are having same number of what you call electrons, which is basically 10 electrons. Okay, isobars, same mass number and different atomic number, like calcium and argon. You can see both of them are having same number of mass number but different atomic number. The same way, isotones, same number of neutrons, which is C16 and 12, N 7 and 13. If you'll see, number of neutrons in both the cases are 6 and 6. Isosters basically species having same number of atoms and electrons. So children, try to understand same number of atoms and electrons. If you talk about CO2 is having, CO2 is having how many atoms? 3 atoms, 1, 2, 3. Okay, 3 atoms. N2O is having how many? N, N, O, N2O. Total we have 3 N2O, I mean 3 atoms. If you talk about electrons, carbon is having 12 electrons, carbon is having 6 electrons, O is having 8 electrons, 8 to the 16. So 16 plus 6, I hope you know, 22. If you talk about N2O, 7 plus 7, 14 plus 6, 22. So electrons numbers are very much same. Okay, next isodiaphers. Isodiaphers means they are having same number of n minus p value. Sir, what do you mean by same number of n minus p value? See, here atomic number of boron is 5, mass number is 12, atomic number of carbon is 6 and mass number is 14. So here children, 12 minus 5 if you will do, you will get 7, and here 14 minus 6 you will do, you will get 8. So these are basically number of neutrons. Let us subtract neutron number with their atomic number, which is 7 minus 5, you will get 2. Here 8 minus 6, you will get 2. So this is what isodiaphers are. So such type of things will come in exam. So remember all these things. Now, average molar mass of gaseous mixture. Children, gaseous mixture, basically here what we are trying to tell you, it is applicable for all homogeneous mixtures, okay, including alloys also. So we'll understand how these things are working. Gases always form homogeneous mixtures, which are non-reacting. I mean, here whatever you are talking about, here you should talk only about those gases who are making homogeneous mixture, and they should be non-reacting nature. And we know gases are always forming homogeneous mixture, heterogeneous mixture. I believe you have read in your childhood, so I don't have to explain. So same gaseous mixture is given. So what you are taking, they have two different what you call mass numbers, and they have what you call different percentage of abundance, which is N1 and N2. So what will be their mass? M1 N1 and M2 N2. I hope all of these formulas we have read, है ना? So children, M average is equal to W total by N total. M1 N1 plus M2 N2 divided by N1 plus N2. Children, as I have told you, number of moles N is equal to given mass by molecular mass, which we know, isn't it? If you want molecular mass, which is average, what will you do? W by N you will do. Here, instead of number of moles of one molecule, you are taking number of moles of mixture. Here I are taking total mass. Instead of given mass, you are taking total given mass. That's it. Same thing we have written over here. M average is equal to total mass divided by total moles, which is M1 N1 plus M2 N2 divided by N1 plus N2. And how would I got mass? We know mass is equal to what? Mole into molar mass. Mass matlab weight, given weight is equal to. So the same formulas we are applying everywhere. Okay, the things which I have learned in our previous lecture. So children, let us understand. We will find out a variety of things. What is the average molecular mass or average mass of air? So let us find out average mass of air. Air is a combination of two things, children, N2 and O2. I hope you all know. Majority of the quantity is nitrogen and oxygen. N2 is also molecule, O2 is also in molecule. It is in 79%, it is 21%. We have read in our childhood classes in, I think, various lectures, isn't it? Sir, other gases also present. They are present, but in minute quantity, so we can overlook. So mass of air is equal to 28 into, means average molecular mass of air is equal to what? 28 into 79 plus 32 into 21 divided by 100. If you solve, we are getting average molecular mass of air as 28.8 gram. Now one more question. Calculate the average molecular mass of gaseous mixture containing SO2 and O2 in 2:1 mass ratio. See, they have given mass ratio first. So find mole ratio and you will get your answer. SO2 and O2, mass ratio is 2:1. So what will you do with mole ratio? Children, mole ratio is equal to mass ratio by molar mass. Very easy. Given number of mole is equal to given mass by molar mass. What is given ratio? Instead of mass, they have given ratio. So take ratio 2 and 1. What is their molar mass, children? It is 64. It is 32. So we are getting 1:1. Equimolar mixture. If equimolar mixture is there, then average molecular mass will be arithmetic mean. Arithmetic mean, how you are doing? M average is equal to 64 plus 32 divided by 2 is equal to 48. Okay. Next question. Average molar mass of gaseous mixture containing NO and NO2 is 38. Then calculate the composition by mixture, that is by moles and by mass. Both you have to calculate. What is mixture's mass, children? 38 they have given. NO's mass is 38. NO2's mass is 46. So what I told you, by moles if they are asking, take percentage of abundance. Percentage of abundance is equal to mole percentage. We don't know, so we'll take it as X. This as 100 minus X. So 38 is equal to X into 30 plus 46 into 100 minus X divided by 100. Overall, children, what we got? X as 40. Overall, what we got? X as 40. So mole ratio is 1:1. So mass will be, children, what will be their given mass? as per this given mass will be 30 and 46, which is equal to their what you call molecular mass, isn't it? Now mass percentage of NO in the mixture will be how much? 30 by 30 plus 46 into 100, which is 39.47%. So the other one will be around 61 percentage, or 60 point something percentage. You can calculate better. So this is it, children. This is our calculation of what you call molecular mass, average molecular mass of isotopic mixture. Okay. If any doubts are there, kindly let me know in the comment section. We'll make it more clear. Okay. I hope you have understood this particular part of the mole concept as well. Thank you.